Welcome to the Deep Dive. Today, we're tackling something truly transformative, the merging of artificial intelligence and quantum computing.
Yeah,
Think of it as like taking two already revolutionary forces and, well, seeing what happens when they join up.
exactly. We're talking about a synergy that could let us crack problems that right now are just, well, they're walls we can't climb over.
Right. And just to give you a sense of scale here, AI right now is already a massive player. It's projected to pump something like $1.35 trillion into the global economy by 2030.
That's huge.
It is. The current market, North America's got about maybe 29%.
hmm
Asia Pacific and Europe are close behind, mid-20s.
hmm
But the real potential fireworks, well, they start when quantum computing enters the picture properly.
And what's so fascinating, I think, is that these two fields, they started out on completely different tracks,
It's totally separate.
AI kind of growing from machine learning, classical computers doing incredible things already. Meanwhile, quantum computing has been exploring the weird and wonderful world of quantum mechanics,
Definitely weird.
promising this massive leap in processing power, but for specific kinds of really tough problems.
And where they're beginning to connect, that's creating some genuinely exciting ideas. The big ones being quantum machine learning, QML,
Yep, QMO.
and quantum deep learning, QDL.
Right. And these aren't just, buzzwords. They signal a fundamental shift.
In what way?
A shift in how we might handle really complex issues. Think about cryptography, keeping data secure,
Okay.
or optimizing all sorts of systems, discovering new medicines, even building way more accurate models of incredibly complicated things like climate or financial markets.
Wow. Okay. So the core of this deep dive then is to really explore what happens when AI and quantum computing actually work together.
That's it. What are the potential game changers? What new possibilities might open up for all of us?
Okay, so we know AI is already shaken things up, but what does the next level look like? Once quantum computing starts to really contribute more.
So the next phase, people often call it quantum-enhanced AI.
Right.
It's really all about using the unique capabilities of quantum algorithms, things classical computers just can't do,
To know what exactly?
to solve problems of extreme complexity and do it with a speed and efficiency that traditional computing just can't touch.
Can you maybe paint a picture for us? Like, where might we actually see these quantum-powered breakthroughs first?
Sure. Imagine financial modeling that can predict market shifts with, far greater precision.
Okay, that's big.
Or in material science, designing entirely new substances like property by property at the atomic level.
Wow.
Think about optimizing logistics on a scale that's currently just impossible, managing global supply chains in real time super efficiently.
That would change things.
And a really significant one, probably sooner rather than later, is healthcare, particularly in speeding up that incredibly intricate process of discovering new drugs.
So these aren't just small tweaks or improvements we're talking about. These quantum-enhanced AI models could really revolutionize entire fields,
Exactly.
unlocking possibilities that honestly feel almost like science fiction right now.
That's the key. It's not just about making existing AI faster. It's about enabling it to tackle entirely new categories of problems that are currently just, intractable.
Now, it's not just a one-way street, is it? AI isn't simply getting a boost from quantum.
No, not at all.
It's also playing a vital role in pushing quantum computing itself forward. How's that happening?
Yeah, this is a really interesting dynamic. AI is proving to be incredibly useful in several key areas of quantum development.
Like what?
Well, one major area is optimizing the quantum algorithms themselves. You can sort of think of it as AI helping quantum programs run more efficiently.
Oh, okay. Like finding the fastest route through a complex calculation.
Pretty much, yeah. Like a performance tuner for quantum code. Another crucial role is in refining quantum error correcting codes.
Error correction. That sounds important.
No, it's critical. Quantum systems are incredibly sensitive to noise, to their environment. That leads to errors.
Right, decoherence and all that.
Exactly. So AI algorithms are helping us develop more effective ways to detect and fix these errors. It's like having a super smart spell checker, but for quantum computations.
That sounds absolutely essential given how fragile quantum states can be. What else is AI doing?
AI is also being used to predict and enhance the stability of the actual quantum hardware.
The machines themselves.
Yeah. These systems are incredibly complex, right? AI can analyze just vast amounts of operational data to find patterns, suggest improvements to design, to function.
Okay.
And finally, AI is assisting in the simulation of quantum systems. This is hugely valuable for researchers.
So.
Well, they can develop and test new quantum algorithms in simulation before they even try to run them on physical quantum hardware. It's like a virtual test lab.
Huh. So AI is almost acting like a superpowered research assistant for quantum physicists and engineers,
In many ways, yes.
helping them design better software and better hardware.
It significantly speeds up the entire process of quantum development. It really does.
You mentioned earlier that quantum computing faces some big challenges.
Yeah.
The systems are delicate, they're expensive, incredibly complex.
Big hurdles.
How is AI directly helping to overcome those inherent difficulties?
Right. This is where AI's sort of problem-solving power really shines. Take designing better error correction codes like we just talked about.
Yeah.
AI algorithms can explore a much, much wider range of possibilities than humans or traditional methods ever could.
Okay.
Similarly, AI can analyze how the quantum devices are performing moment to moment and suggest the best settings, the best tuning to get the most accurate and efficient results.
So AI is actively making the quantum computers themselves more reliable and, well, better performers.
Exactly. And furthermore, AI can optimize how we use the limited quantum resources we have,
What do you mean?
like deciding which specific quantum bits or qubits are best suited for different parts of a calculation based on their current stability or connectivity.
Resource allocation, basically.
Precisely. And maybe most excitingly, AI is proving to be a powerful tool in actually discovering new and better quantum algorithms.
Really? How?
It can spot patterns, suggest innovative computational approaches that human researchers might not immediately think of. It accelerates discovery.
That's fascinating. So AI isn't just something that uses quantum computing.
No.
It's something that actively enables it to get better faster.
That's a really key insight. These technologies aren't just interacting, they're boosting each other forward. It's a virtuous cycle.
Now, this doesn't sound like just theory anymore. Our industry is actually starting to integrate AI into their quantum research and development work.
Oh, absolutely. We're definitely seeing a growing trend. Industries are incorporating AI-powered tools into their quantum R&D processes.
What kind of tools?
Things like AI-driven platforms to automate the analysis of the huge amounts of data quantum experiments generate. That's often a bottleneck.
I can imagine.
And also tools to help manage the sheer complexity of controlling and monitoring the quantum hardware itself.
And what about the people? The workforce? Are they getting the skills they need to navigate this AI quantum world?
Yes, there's definitely a clear understanding of the need for upskilling. We're seeing the development of AI-driven simulation and modeling tools,
Okay.
specifically designed to help researchers and engineers better grasp and work with quantum systems. It's about preparing a workforce that understands both sides.
It sounds like there's a deliberate and structured way these two fields are coming together. What does that integration process typically look like for, say, a company?
Generally, yeah, it involves a few key steps. First, organizations need to identify the specific areas where combining AI and quantum could offer the biggest bang for their buck.
Makes sense. Find the leverage points.
Right. Then, they usually start implementing AI-powered quantum software tools and using machine learning techniques to fine-tune their quantum hardware for better performance.
So it's not just randomly throwing AI at quantum problems and hoping something sticks.
Not at all, no. It requires developing AI algorithms that are specifically designed for the unique characteristics of quantum environments, quantum data. That's important.
Okay.
And finally, there's a crucial step. Continuously evaluating how these integrations are actually performing in the real world, and then, refining and making adjustments as needed. It's iterative.
It sounds like this kind of well-thought-out combination leads to a more flexible, maybe more cost-effective, and ultimately smarter quantum infrastructure.
Precisely. It's about creating a quantum ecosystem that can learn and adapt over time.
Now, for those listening who are thinking, okay, this sounds amazing, but how can I actually get involved or learn more? You mentioned an AI plus quantum certification. Tell us a bit about that. Who's it really for? What does it cover?
Sure. So the AI plus quantum certification by AI Certs, it's designed for a pretty wide range of professionals who want to be right at the forefront of this convergence.
Like who?
Well, AI specialists looking to add quantum to their toolkit, definitely. Quantum researchers who want to leverage AI's power. data scientists looking for new computational frontiers, and tech innovators, entrepreneurs who want to understand and build the future of this space.
And is there a real economic opportunity here? Is this a growing field?
Oh, absolutely. The market for AI and quantum computing is projected to grow significantly. The numbers suggest around $4.2 billion by 2033,
Wow.
with an annual growth rate over 33%.
Okay, that's rapid growth.
It really is. That kind of growth suggests a strong and growing demand for professionals who really understand this intersection.
So what specific knowledge, what abilities does this certification actually provide someone?
Okay, so it starts with a solid foundation, right? An overview of both AI and quantum computing principles, get everyone on the same page. Then it really dives into the fundamental building blocks of quantum computation, things like quantum computing gates, circuits, algorithms.
The nuts and bolts.
Exactly. You cover basic operations like polygates, understand multi-qubit systems, CNOT operations, which are essential for creating entanglement and doing complex quantum calculations. Think of these as the basic instructions, the assembly language for quantum computers.
That sounds like the core knowledge you'd absolutely need. What about the algorithms themselves, the specific quantum ones?
Yeah, the certification explores key quantum algorithms that are relevant to AI. Things like Deutsch-Jutze and Bernstein-Vazirani. These are important because they clearly demonstrate quantum speed advantages for certain types of problems. It also covers Grover's search algorithm.
Ah, I've heard of that one.
For searching, exactly. It offers a significant speed up for searching through large, unsorted databases. Instead of checking, potentially half the items on average, classically, Grover's can find it much faster, quadratically faster. So for 1 million items, maybe around 1,000 checks instead of 500,000. It's a big difference.
Definitely.
And also the quantum Fourier transform, which is a fundamental piece in many other quantum algorithms used for things like optimization and finding repeating patterns, periodicity in data. We really highlight how these offer advantages over classical methods.
And then does it move into the more advanced areas, like actually applying these quantum ideas to machine learning?
Absolutely. A significant part focuses on quantum machine learning, QML. This explores how the unique properties of quantum mechanics, superposition, entanglement can be harnessed.
To do what?
To potentially solve high-dimensional data problems much faster than classical ML algorithms. Participants learn about specific QML techniques like quantum support vector machines, quantum k-nearest neighbors, quantum proximate optimization algorithms.
So quantum versions of familiar ML concepts.
Kind of, yeah. But leveraging quantum phenomena. These techniques show promise in areas like pattern recognition, complex optimization, handling data that's just too big or complex for classical methods.
And I imagine applying quantum to deep learning is also covered. That seems like a natural fit.
Indeed. The certification delves into quantum deep learning as well, exploring the architectures, the potential of quantum neural networks, quantum convolutional networks, perhaps for image data,
Okay.
quantum GANs, generative adversarial networks for creating new data samples, quantum recurrent neural networks for sequential data, like time series, and quantum variational autoencoders for efficiently representing complex data. It covers the whole emerging landscape.
Wow, that sounds incredibly thorough on the technical side. What about ethics? That seems like a big consideration here.
Very much so. The certification specifically addresses the ethical implications. Things like data privacy in a quantum world, security challenges, ensuring equitable access to these powerful technologies, and crucially preventing misuse. That's a core component.
Good, that's essential. And how does it keep people current? This field moves so fast.
Right. It also looks at the latest trends and the future outlook, rapid research developments, platforms like IBM Qiskit that people can actually use,
Okay.
the rise of quantum cloud services, making quantum hardware more accessible, and just the increasing investment pouring into the field from tech giants and governments. It gives you context.
It's one thing to understand the theory, but practical experience feels crucial here. Does the certification offer, like, hands-on work?
Yes, absolutely. It culminates in hands-on workshops and real-world case studies. Participants get practical experience.
Doing what, for example?
Working with techniques like quantum support vector machines on standard datasets, like the Iris dataset for classifying flowers, developing quantum variational circuits, and even getting practical exposure, practical access to IBM's quantum computers through their cloud platforms.
Ah, so it's not just learning in a vacuum. It's about getting your hands dirty with these cutting-edge tools.
Exactly. That practical element is key.
Now, we touched on this earlier. Organizations can really struggle with adopting AI generally.
It's a known challenge.
A survey you mentioned found, 42% of employers said lack of AI skills was the biggest barrier, plus cost, tools, integration issues.
Yeah, the skills gap is a major one, along with all those other factors.
So how does this certification help bridge that gap, especially when you add the extra complexity of quantum computing into the mix?
That's a really important point. AI Certs directly addresses this skills gap by offering specialized practical training. It equips individuals with the specific skills needed to operate right at this intersection of AI and quantum.
Okay.
It's about creating a workforce that isn't intimidated by these advanced technologies, but can actually actively work with them.
So it's about providing real applicable skills, not just, high-level theoretical knowledge.
Exactly. Their whole approach is centered on building what they call an AI-ready culture within organizations.
What does that mean in practice?
It involves not just the initial training, but also encouraging continuous learning, fostering collaboration between, say, AI teams and quantum researchers, and providing that hands-on experiential learning through real-world projects and case studies.
Right.
The goal is really to empower professionals, give them the cutting-edge knowledge and the practical skills so they can immediately apply what they've learned to relevant projects to actually drive innovation and get tangible results.
It really sounds like it's about empowering individuals to not just sort of watch the future happen, but to actively shape it.
Precisely. It's about moving from just understanding the theory to being able to practically implement it and potentially become a leader in this really transformative field.
So to kind of bring it all together then, it's crystal clear that this convergence, this meeting of AI and quantum computing holds just incredible promise.
Absolutely. I mean, we really do seem to be on the verge of a major technological leap thanks to this powerful combination.
It really makes you think, doesn't it? For everyone listening, are you ready? Are you ready to be part of this next wave of innovation?
That's the key question, I think, for you to consider.
If what you've heard today has sparked your interest, maybe piqued your curiosity, and you want to explore this exciting area further, definitely head over to www.acerts.io. That's AICERTS.io. It's a fantastic resource for learning more about this AI plus quantum certification and maybe taking that next step.
It really is an opportunity, I think, to establish yourself as a forward-thinking professional, a real tech visionary in this rapidly evolving landscape.
Absolutely. Well, thank you for tuning in to this deep dive into the truly fascinating world where AI meets quantum computing.
Thanks for having me.
Until our next exploration, keep diving deeper.